And now that everyone can hear us, welcome back to the ICPC Neural Network Challenge. I would like to introduce to you Greg Hammerly, who's been problem setting and the main judge for that competition, as far as I'm concerned.
That's right.
Welcome to the ICPC Live.
Thanks.
Here we have a problem set for today's challenge. You can also find rules, additional information, and other data on challenge.icpc.global. But now I'd like you to introduce the problem and let us know about it.
So this is a problem about training neural networks, and neural networks are a well-known technique in machine learning. This is a special kind of neural network, which is a binary neural network. And the reason we're working on a binary neural network is because they are fast and efficient to compute with, but they are in some ways more difficult to train than traditional neural networks because of the binary nature. So it's a more combinatorial problem than a standard real-valued neural network. In a real-valued neural network, you usually use an algorithm like backpropagation that may or may not work well here because of the binary nature. So the task that they're given is to classify different images of handwritten digits, and this is a classic data set. It's called the MNIST data set, and it's images that were gathered, tens of thousands of images of people writing numbers on paper, taking pictures, and then they were digitized. And these come not as the image input, but as a version, a compressed version of that, as input to the neural network. And then their goal is for each image to predict whether it's a 0 or a 1 or 2, 3, 4, 5, 6, 7, 8, 9. And I introduced this when I teach neural networks at Baylor, and one of the reasons that you might want to do this is if you were routing mail, and you're the post office, you take a picture of the envelope, and then you might get the postal code, the digits on the postal of the postal code, and then if you can segment those and then you can predict those correctly, then you can automatically route the mail, for example. There's lots of different applications. You can automatically recognize the numbers that people write down. That's lots of applications where that's useful. So the goal here is to try to predict those images with the highest accuracy possible. And there is training data that they are given, and they use that on their own computer to train the neural network. Okay. And then the evaluation, the accuracy, the score that they get is based on hidden test data that they do not have access to.
But they can see the score for the hidden test data right away, right?
Exactly.
So we're not hiding any extra information. And exactly after the contest end, which will last in total 3 hours, we'll get the final results right away.
That's right.
Okay.
That's right. And I believe there are going to be prizes for the leaders at the hour 1, hour 2 mark as well. So that'll be good. The neural network that we're using is illustrated here. I don't know if they can see this, but if you look at the problem statement, this is too small.
It should be available on the challenge.icpc.global, so make sure to visit the website. Right,
and the website for the contest where they can see this is submit.icpc.global. And the rules are of the challenge. So the inputs are fed into a set of 150 perceptrons, and a perceptron is a traditional neural network decision surface. And the outputs of those are each plus or minus 1, which are then added together to these sum nodes, which then get there's 1 per class, and whichever one predicts the highest value, that's the value that the network predicts.
Okay, so at the moment, with just 22 minutes elapsed from the competition, we already can see teams earning some scores. Yeah. So how good is 78?
So 78 is okay. So I'm looking at, these are 2 different versions of the problem. I introduced the 10 class version. There's also a binary class version. So the problem A is 10 classes predicting 0 through 9. Problem B is predicting either a 0 or not a 0. Okay. And so that one is actually much easier to get at least 50% because half the data are zeros, half the data are not zeros.
So more random solutions actually earn much more points in the problem B.
Exactly. And so you're expected that if you submit just any set of weights, you'll get about 10% on problem A and about 50% on problem B. So 60% is kind of the baseline. So if you're at 60 or 70%,
or maybe you submitted quite a number of times and then just randomly figured out how to work.
Yes.
Can you elaborate on the process of submission? Because that is very untypical for programming competitions.
Yes.
As far as I'm concerned, and you mentioned that teams submit weights within the neural network.
That's right.
How does that work and what happens further?
So the information that they're submitting is primarily these plus or minus 1 weights at the bottom layer of the network. And they submit a program which simply prints, all it has to do is print those weights. They could do a little computation while they're at it, running on the judge server. But the main thing that they need to do is print those weights. So they can submit a program which all it does is print a bunch of ones or a bunch of negative ones or random values. That would be a simple solution.
Not only integer values, but also any values.
They're expected to print plus or minus 1.
Oh, okay.
If they submit something else, we just round it to plus or minus 1.
That's useful.
Yeah, we're helpful that way.
Okay. What happens further in the system? As soon as team submits 3 digits for every single neural network connection, then you run the model within the cloud system, or what happens?
Right, so we read the weights that they submitted. We use that in our own judging software to implement a neural network exactly like this, but use it on the test, the hidden data, and then we compute the prediction that the network makes, that their network makes, on all of the test data and discover whether or not they got each one correct, determine an accuracy, and that's their score for that problem, for that submission.
Is the test data in any way typical? So I know that for a number of machine learning problems, there exist benchmarks that are well known and that everyone competes against. So is it true that for this particular problem, which you said can be quite renowned, the test data is also a fairly representative benchmark that everyone uses? Or was it generated purposely for the challenge?
The original data is a benchmark. So MNIST is a benchmark data set that a lot of people use. The actual data that we are using is derived from that benchmark using a compression algorithm. And it was not done by me, so I can't tell you much about that compression algorithm. And so having the MNIST data set doesn't help you that much, even though it's publicly available, because this is a derivation of that data.
Okay. What would you do if you are to solve that particular challenge in 2 hours? And I would split the problem into 2 parts. So what would you do if you have just 1 hour for problem B? And how would you improve your solution for problem B with just the binary options, given the remaining time of the challenge?
For problem B, I would probably start by what they're probably doing, which is submit something, any set of weights, see what I get back, and once that tells me it's about 50%, I would say, okay, let's move on and try to discover which of those 51 bits of input gives me the most information. So which of you can run some sort of correlation between each of the 51 input bits and the output, which is either 0 or 1 for that problem. And then I might say, well, if there's a correlation between some bits, I would set those values to plus or minus 1, depending on which way the correlation is going.
But essentially it means that you would solve a black box problem without even knowing what the problem itself is, knowing that there is just 2 possible outputs.
Right.
You'll reverse engineer the, say, testing system to give you the most score possible. Will that approach help you towards solving problem A? Or would it be something different?
Yes, I think there are a lot of... I've tried a few different solutions, but I think it'll be interesting to see what the top teams come up with. I'm sure they'll come up with something completely different than what I've thought of. There are lots of potential solutions, since you can treat it like a black box, like you said, and try to optimize it in any number of different black box optimization ways. So trying random walks, trying to find correlations, are very different approaches, but they can both lead you to high accuracy, I think. Another interesting technique would be to use either a solution that you were finding for problem A as a starter for a solution for problem B, or vice versa. And I think that actually may pay some benefits.
Okay. Well, the ICPC challenge is part of the larger ICPC World Finals event. And we know that competitors who are here now and who compete in the challenge are somewhat very used to algorithmic programming.
Yes.
Do you think some of them would opt for a more algorithmic and, say, straightforward in that sense approach, and try to first write a solution that will correctly determine every single number as 0 or 1, and then try to re-implement that as part of the neural network?
So I have 2 responses to that. One is, I'm a machine learning guy, as well as an ICPC person.
Indeed.
But so I'm very happy about this and very willing to say this is the right way to be. Like, there are better solutions, there are worse solutions. There's no single best solution. Well, there probably is, but there's no single best solution that we can just say that's it, and it's going to be the best, and we can prove that it's the best easily. And the second thing is, we live in a world of uncertainty, and this reflects that, right? And so I think this is good for that. If people don't like that, that's probably a matter of preference, but I think it's an excellent way to go.
As far as I understand, the challenge itself, the problem, was proposed by you. So is it, in your opinion, the best way to start your introduction to neural networks and maybe machine learning in general, from the task that can be, say, implemented by you without neural network, but then you can also research into the ways of how that actually can work with neural networks?
Well, so I can't take credit for the whole task. I sort of shepherded it to completion. I worked with the folks at Huawei to help get this going, and they proposed the original idea. So I do think it's a reasonably good introduction because it shows all the parts of the machine learning process. It skips over some of the standard algorithms that we would. It's more combinatorial than the typical machine learning algorithm approach. So it skirts around that, but I think in that way it makes it more ICPC friendly, because if you were to implement the standard machine learning approach for training a neural network, you would spend almost the whole or at least I would, as a slow programmer, would spend almost my whole 3 hours writing the backpropagation algorithm, and then I would have no time to train it. So I think. But I think as far as getting the core parts of what is a neural network, how does the information pass through it, how can we make it better, yeah, all those parts are there. So this is a good introduction. You can certainly see a lot of avenues of how you can improve it from where we're starting.
We know that this year it is theoretically possible that it would be the first time an interactive problem is introduced during the World Finals. There's been a mention that it is theoretically possible, and even though it usually takes a few years till the problem itself gets to the World Finals, just to make everyone comfortable with the idea, do you think that the next completely different type of problem that will be introduced in the World Finals will be machine learning related?
I don't know. That's a good question. I can't say that I have any special knowledge of that, so I won't speculate.
But you would definitely be happy to see that area of knowledge covered in the ICPC
very much
Finals
so.
problems. Because in some of those regional problems, and I'm personally from Russia, so New York would be my regional contest, sometimes we introduce problems that indeed involve non-full solutions, but to properly incorporate that into the ICPC environment, you need to get at least specific percentage of answers correct on each single test. That kind of allows you to, on one hand, once again, submit about 20 solutions and then get a little better result than on average. But on the other hand, lets you introduce that new type of problem into the standard environment of read an input or write an output.
Yeah, and it's fun, right? It's breaking out of the mold a little bit and trying something new. It's fun to see what different regions of the world tend to do, and they have all these different types of problems. And I feel like I've been doing this for 20 years, and I still keep hearing about new different types of problems.
Absolutely,
it's fun.
That's the best part of ICPC.
Yeah.
Okay, so we can definitely see a huge improvement on top of the scoreboard.
Yes.
So Harvard University submitted a solution for both problems and is now up to 100 score points. The total possible theoretical maximum would be 200 points, but what score do you expect to have at the end of 3-hour time for the world finalist teams? Not just your average student.
Yeah, well, I'm not sure I want to say, but I'll give you a range.
Okay.
My top range prediction would be around 170 to 190.
Wow, that is a very large number of correctly guessed examples. What is the best way to evaluate your solution locally if you're a world finalist? Are they given the example of the neural network that they can run locally to test against?
So I wrote a Python script that they can download from the problem web page, and you run that, and you give it a set of weights and a data file, and it will tell you the accuracy. It will also tell you the confusion matrix, which is the set. It's like the 10 by 10 table of what you predicted and what was the actual answer and how many times you did those, so that you can see where am I making my mistakes and where am I getting them correct.
Is it more typical to mistake one specific digit for another? I'm not sure. I've been always messing up once with sevens. Because I think some of my classmates had terrible writing, and they were just the same digit every single time.
Right. Well, yeah. I mean, like when I lived in Belgium, my teacher would write a number on the board, and I thought she was writing a 7 because she would use a very large swoop to begin, but it was actually a 1. And so it was a 1 with a very large swoop. And yeah, so different people, that's what makes this data set interesting, is because people have lots of different strange, well, it's not strange, but very varied ways of writing. So I'm not, it's a good question that you're asking, whether there's going to be a bias in a network for one class over another. I'm not sure I can say particularly, but if there is, they will see that through the confusion matrix. So, but it's a typical problem in machine learning, especially if there's a class imbalance, which there is not here. But if you have a class imbalance, and like let's say we had many times more zeros than ones, right? Then you could see with the confusion matrix where you're making the mistakes because you're biasing the ones over the zeros or vice versa.
Oh, and now University of Zagreb is going up to the 2nd place with a great submission on problem B as well. But once again, the problem B should be fairly easy. Is the accuracy of 100 on problem B achievable?
I don't know.
Did you achieve?
I did not achieve 100.
Accuracy?
And I'm happy about that because I feel like it leaves some headspace for the contestants to really show us some good stuff.
How does the development of such problems work?
In terms of, well, so it's a pretty standard machine learning technique of you train on some test data, or training data, you test on some other set, and you keep those completely separate, obviously, so that you're not biasing your training data or your testing data with your training. And so I just took that framework of this is a standard way of teaching machine learning and evaluate and doing research in machine learning, and applied that to, well, let's give them some training data and let's evaluate it. So the only trick was making sure that the classes are balanced, making sure that the problem is clearly described so that people who have never done this before can understand it, I hope, and then making sure that the evaluator is robust and is going to work efficiently.
You chose the 3-layer neural network, as I can see from the statement. Why?
It's a pretty common. So again, this is an introductory problem. So it's a fairly common. Wow.
42 points.
42 points. That's a big jump. It's a fairly common structure to have sort of 2 or 3 layers in a neural network. Now, interestingly, the Turing Award was just given to Jeff Hinton and Yeshua Bengio, and I'm blanking on the last name, unfortunately, just 2 weeks ago, and for their work in deep neural networks. And with deep neural networks, of course, they're far more than 3 layers, and the interesting thing there is that you can learn all kinds of interesting features with far fewer weights. But we decided to go with more traditional neural network, which more people have seen, and it's a little bit easier to reason about.
I see. Well, that makes sense.
Yeah. So this is in many ways a standard. More reasonable, a little bit more tenable. There are fewer weights. There's still a lot of weights, but there are fewer weights.
You only have 14 connections from layer 1 to a single point
15.
On layer 2.
Yeah, there are 15 for the first class, 15 for the second class, and so on. So the first layer perceptrons are not connected fully to the next layer, the sum nodes. And that's what allows them to specialize. These specialize in recognizing zeros, these specialize in recognizing ones, and so on.
Okay. The input for the neural network is a bitmap.
I'm sorry?
Is the input for a specific run, for a specific symbol, is a bitmap?
It's not a bitmap. It's a vector of 51 ones and negative ones.
But
binary.
Then they can be transformed into a rectangle with every single...
No. So the compression algorithm that we used took the original 28 by 28 pixel image and compressed it down to 51 bits. And we don't have an inverse, or we're not providing an inverse for that.
Oh, so you cannot actually reconstruct a single input back into a digit.
You can't look at it. That's correct. At least not directly.
Wow, but that makes the problem much more difficult to solve, say, manually in a way.
But you do know, so I mean, one way to think about it is just treat this as this is a 9 because we've been told it's a 9, and these are the 51 bits that represent a 9. And you can think of those as pixels. You just can't visualize them as pixels, right?
Wow. But essentially, it means that these could be not just digits, but any kind of objects that can reasonably be serialized into 51-bit.
Sure, absolutely, yeah. The inputs here could be representing any. I mean, we could be doing a face. We could do the same task where we took the original images were faces instead of handwritten digits, and the 51 bits represent the face data that we originally had.
Right. That's very interesting. What would happen if you will need to change the task data in the very last day? What would be the other domain that you would do?
Well, I'm glad I didn't have to do that.
Well, you should always have a plan B, right?
Yes. That's a good question. I would probably find another data set. There are many other data sets that have to do with handwriting. And I think a lot of them are interesting. Of course, there are a lot of image-based data sets, and since deep neural networks in particular, and neural networks in general, are really good at image recognition tasks, I would probably opt for some sort of image-based task. Which one, I don't know. I'd have to look and find one.
Wow. Okay. The next question would be, why digits? I mean, it could have been letters, right? But letters and handwriting are much more difficult, I assume.
I imagine there's more variation, yes. Especially since there's cursive and non-cursive and different character sets and different regional ways of writing and that sort of thing. But so I think handwritten digits are more standardized and more recognizable. And this is just a classic data set, so it's a good way to begin.
Oh, that's cool. Oh, we have a new leader. University of Tokyo.
Excellent.
Submitted problem A much significantly for 56.36 points.
Good.
And improved that right away up to 73.79. What happened in between of these two submissions? What do you think? Did they just resubmit the same submission? Is it possible to actually get such diverse values in the same submission?
I don't think so. So if your submission has some randomization in it, I don't expect that you would vary by that much, by 20% or so.
What's the most reasonable threshold on that?
I would think it would just be a couple of percent. So I think if they're getting much better solutions, it's probably because they're finding much better networks on their own machine and then submitting those fixed weights. But I could be wrong.
Okay. Let's talk a little about the system that we're submitting to.
Okay.
So that is the system that is well known for most of the ICPC finalists because the CADIS judging system was running an online judge for past World Finals problems for many, many years already. But this time we're using the Cloud CADIS version. Are there any specific differences apart from the fact that the computational, the computers that actually evaluate the solutions are located somewhere in the cloud?
There are more languages available, which is not terribly relevant for this problem, but they could use Haskell if they want.
Okay.
They can submit in Haskell. Or
sounds exciting.
I don't program in Haskell, but they could. But otherwise, no. The servers are in Stockholm, but otherwise they're basically the same as what they've used in the past in the ICPC World Finals.
Well, and they continue to use that even now for the Shadow CCS system.
That's right. That's right. This year and last year, DOM Judge has been the primary CCS, and CADIS has been the Shadow CCS.
Okay. Well, we see quite a lot of movement in the top of the contestants' scoreboard.
Yeah, this is interesting.
But I also would like to remind everyone that it's not about just contestants. Even though they will receive 15 top teams will receive great prizes from Huawei. So that should be an exciting competition. But we also expect to see some action in the coaches' scoreboard. So every coach for the team was also given a login and password. And we can see a lower number of coaches in the scoreboard, but still some of them are doing quite good. I think that 69 points is fairly a remarkable result for a coach if that's the first time he works with the neural networks.
Yeah. I'm glad to see them participating. We were excited. I'm excited that I'm a coach, right? When I have my teams at Baylor, and anytime I get to participate, it's also fun. So usually don't get to, but I'm so glad that they're actively participating, because this is something that anyone can approach.
Well, for contestants, the good part of the neural network challenge is fairly obvious. They're introduced to a new technology that is very hyped and popular right now, and so with a high probability, that would be something that they will use and further in enterprise software development, or at least knowledge of this way of solving problems.
Yes.
It would definitely allow them to approach much more problems faster, instead of just writing a full algorithmic solution and trying to achieve 100% accuracy result. They will be able to, say, black box that solution fairly quickly. But do you think that actually introducing coaches to neural network competitions in a way will help them to add machine learning techniques into their educational programs?
Sure, yeah, of course. If they're already familiar with it, then so much the better. But if they're not, and this is a learning experience, and that's good too. While you were talking, it was reminding me that one of the things that I failed to point out or didn't point out earlier is that machine learning is very much a buzzword, right? And so everyone says, well, just use machine learning, as if machine learning itself was a black box.
Indeed.
And one of the things that this challenge emphasizes is the division of labor between training, which they're doing, which the contestants and coaches are doing on their own computers, and they're working hard, and it takes a long time often to train, versus testing. And the testing, the evaluation, once the network has been trained, is very quick. So I think when I speak to people who haven't had background in machine learning, they think, well, where is the machine learning happening? Well, it's not actually happening often on your phone or on your small device, and that's the point of this challenge, is that you're training something on a heavier weight device, a laptop or a cloud server. Well, they're not using cloud servers, but you could. But not for this competition, but one could. Right? And once you're done, then you have a fixed network, and then you could. The whole point of using a binary neural network for this challenge is that that's a very small, efficient neural network, which could be implemented efficiently on a small piece of hardware, a phone or an embedded device, and then no more training needs to happen at that point. It could, but the training is done, and then it's the application of the machine learning that already happened.
Oh, we totally missed the highest possible scores on the problem B at the moment. We have quite a few teams already reaching to 90 points and more. So the maximum now is University of Tokyo problem B 95.61. But there is another team hitting 95.56 just a few times back. That's University of Warsaw. And what do you think would happen if they are to submit the solution from problem B into A right away? Is it just is it really easy to adapt existing solution for B without, say, reading problem A, just knowing that you have 9 digits instead of 1, instead of 2, excuse me? So
you have more weights that you need to submit. You have 5 times more weights, so you would have to...
What if I just copy-paste them?
Right, exactly. So if you copy and pasted the weights from B to A and then padded that with, or duplicated it, I expect that would do much better than just a random solution.
Okay.
So that's, like I was saying a few minutes ago, that would be a reasonable way to start working on one problem and then moving to a different problem.
Wonderful. Thank you very much.
You're welcome. Thank you.
Expect you to have to be back to the studio occasionally during the course of the challenge if you want. So thank you very much and have a good time.
Thanks.
And now we would like to introduce 2 guests to the studio. Guests would represent Huawei company, and they've been introduced into working with that problem. Please take on the headphones. You're welcome to. Oh, no problems. We can turn it on. Well, you're much more ICPC then. Okay. Let's do a short sound check. I'm sure that you can hear me now.
Yes.
And now you can hear each other as well. welcome to the ICPC Live. Once again, we're now in the third part of the ICPC Neural Network Challenge that is powered by Huawei this year. We've just discussed the problem and the academic part of the Neural Network Challenge, how it will, we hope, impact the future of contestants and through introducing them to neural networks and machine learning, and maybe even coaches who I hope that will see that as an opportunity to introduce machine learning into the computer science courses. But I'm sure that the most important part is definitely the application of such problems into professional programming, to real enterprise engineering. So can you introduce yourself and then elaborate a little on that?
Okay, so my name is Merwan Deba. I'm a director of the Mathematical and Sciences Lab of Huawei in Paris. And,
just a second.
yes.
I will need you to fix the microphone to be a little closer.
Is it better? Can you check?
Yes, much better now. Thank you.
Is it still better?
Yes.
Yeah? Okay, good. So my name is Merwan Deba, and I'm director of the Mathematical and Sciences Lab of Huawei. We have roughly around 100 mathematicians working on different topics related to the business of Huawei in Paris.
Wow. What is their background? Is it, you say mathematicians because that's the primary point of interest, or some of the graduated software engineering proficiencies?
So all the people in the lab have PhDs in roughly domains of what we call applied mathematics, which is roughly signal processing, optimization background, coding, number theory, information theory, AI, machine learning, and other aspects of that. So it's not a pure mathematics, it's mostly applied mathematics, where they use advanced mathematical tools with a profound understanding of those tools to apply them in the different ICT business, information and communication technologies of Huawei.
Wonderful. And for you?
I also work for the Paris Research Center of Huawei, and I am one of the Huawei people who designed the questions for this contest.
Wow. So right now at the top of the scoreboard there's a team from University of Tokyo with scores 169. So Greg mentioned that actually he personally expects the score at the very final moment of the contest to be something around 170 to 190. Are you surprised by the results this team achieved at that moment? So we have 51 minutes elapsed of the contest time. Do you think that there is still much more room for improvement?
Yes, I'm quite surprised. One of the challenges for setting up the questions was to have questions that are not too hard, but also not too easy.
Indeed.
And maybe we run the risk of them proving too easy for some of the teams.
It is indeed very difficult to prepare a problem for such a diverse group if we're talking about the prospect of their experience in the area of machine learning. Because some of the contestants, as we've learned yesterday through the registration, are freshman year students in their bachelor's degree, and it would be very surprising to expect them to have, a deep knowledge of machine learning. On the other hand, some of the contestants graduate their, say, master's degree, and they can already have full hands-on experience on that. Why would you select the problem? Greg mentioned that that's a very classical problem in the area of machine learning and specifically neural networks. But why this specific problem? Maybe you have any more points to add to that.
Yeah, so basically you have to know that Huawei has been building a strategy of having AI, basically what we call pervasive AI to be more clearly, in every device and also in the network. Which means basically that you need to be able to compute AI basically on the phone, basically on the cloud, on the edge, and things like that. So it turns out that computing AI is a bit of a big issue. Okay, there's of course the algorithmic point of view, but also the computing, because you run up with consumption problems, things like that. So having basically a problem which specifically addresses the issue of, I would say, low complexity AI in general, was one of the heart of our problems today. So this is why we decided to build up one of the problems, which was taking us since more than 6 months, working hard, and several teams in our company have been trying to work on that. Of course, there are two parts, one of which I call the fundamental part. We didn't bring it here because we thought it would take too much time. Absolutely. And the other part was mostly algorithmic. And there we decided to bring it here. And then as my colleague Spiros has just mentioned, in general, when we didn't give exactly all the problem that we had, we gave, I would say, a more simpler version of that problem, because it's exactly on how to design a problem for people who we didn't know if they had a good background in machine learning or not. So we think we designed an optimal problem where all the teams can have fun, because I think that's the purpose. And where basically, because of course, if the problem is too difficult, everybody's blocked, nobody's happy. If the problem is too simple, then everybody gets the result, and then we cannot rank the people. So we think we came up with a good mixture, and we're very eager to see the results we're going to get within these 3 hours and the last 2 hours which we're having now.
Well, it's looking good so far. Well, indeed, the ICPC challenge this year is a great blend of what modern software engineering, enterprise software engineering, and state-of-the-art research looks like, together with the ICPC classic algorithmic approach. And one of the points is that we can see that every team works on a single computer. How more effective do you think they would be given 3 computers per team on this competition?
I think that having 3 computers per team would allow them to try different things in parallel, and not only on paper, but also try them, code them, and see how they work at the same time. You know, it's a trade-off.
Indeed.
Between having more computing power and be able to try things in parallel, and also collaborating and try things sequentially on the same machine.
What would be your top 3 approaches to work on that problem if we were to sit in a team? So I would be happy to code whatever you tell me, but that would be my first introduction to neural network challenges. What should I do?
Well, it's an interesting problem because it has the flavor of a machine learning problem, but also because of these binary weights, it can be formulated as a combinatorial problem. So almost any combinatorial optimization algorithms can be tried to solve this problem, and this is what makes it also what we advertised, that you do not actually need a machine learning background to be able to tackle this problem. But but I'm sure that the machine learning background, if you know about training neural networks, it will help you. Mm-hmm. But it's not a prerequisite, let's say.
I see. As Greg mentioned, every team is given a set of data that they can learn on and test locally, and also oh my goodness, we need to definitely interrupt that. We now have 2 universities being on the very top. University of Warsaw indeed submitted problem A. They had a very high score on problem B for a few minutes already, so they were able to, as Greg said, copy-paste the values for A's and B's into for 0s and 1s into every other cell and get a great result. So we have 2 clear leaders on that, but we hope to see much more improvement in the coming minutes. So once again, every team is given a set of public test data they can learn on, and also a Python script that allows them to evaluate their solution locally on that data to see how that works. Why Python? Do you think that would be the, as we know, most of the contestants code in C++. I'm sure everyone can read Python, that's the great part of that language. But why did you choose Python for that purpose?
Well, I think Python is nowadays becoming the most popular language for machine learning. There are a lot of libraries for neural networks, machine learning in general, written in Python. And so that's why it has become very popular. So for other applications, I was also programming in C++, and now I'm switching to Python because I'm doing more machine learning in my daily job.
I see. What is your go-to programming language?
Yeah, I think Python is, I mean, in general, people put AI and Python together. And the main reason is exactly the fact that it's de facto language which enables you to have an easy way to implement these neural networks that we're building. And then, as my colleague said, there's already a lot of available, I would say, scripts over there that people have already coded in Python. So it enables you also to have a very fast implementation. And I think this is why people use mostly Python, and we decided also to go on that trend.
My next question would be highly controversial, but I've been waiting for a long time to ask that. Indeed, as you mentioned, basically all machine learning libraries are written in Python, just as well as, say, mathematical engineering and computational mathematics and computational modeling back then was all written in Fortran and so on. Python is, as we know per programming competitions, not the very fast and in that way efficient language to do computations. And do you think it is indeed a problem that all machine learning is written in Python, which means that essentially given the same amount of electricity in computational resources, Python programs can they process less data and do less iterations than C++ or specifically C, for example?
I think you're hitting the point exactly of our competition. The competition where I mean, at least the purpose and the objective was exactly to do a low consumption based AI, I would say, approach, because basically we want to run our AI algorithms more and more on our mobile phone. At the moment, the majority of AI things which are run on the mobile phone is mostly about the inference, but not the training. So you don't do the training on the phone. And it's done on the cloud, and basically you have all the resources. And now that you're doing more and more training and inference on devices which are limited in terms of resources, then you have to revisit the way things are done. So at the moment, this is what my colleague was saying, how to implement a binary structure of neural networks, for example, will push you to maybe revisit the way we program languages, and maybe you will find a new way, or maybe even a new language, specifically tailored to the hardware implementation, because this is exactly what we're targeting.
And also, although a lot of libraries in machine learning are written in Python, Python is just the script, the programming script, and underneath there might be C++ or other machine level languages that do the hard job, that do the parallelization and all the computation.
So there is no need in crusade against Python in machine learning, right? It should be a fairly reliable language for the upcoming years and for the machine learning development.
I think so. Yeah.
Okay, that's great. Do you think we will see a machine learning problem as part of the World Finals themselves? Definitely not this year, but maybe in the future. What would the problem be? How do you think that can be incorporated in the ICPC competitions?
I think so. I think so because basically we're just saying basically how in different, I would say, universities, computer science is becoming more and more machine learning. Many people are following that trend. So for sure, I think there will be more and more, I would say, AI and machine learning, I would say, problems which will be proposed in ICPC. The second thing is also the challenges which are totally open in machine learning. I mean, we are, I think, just scratching the surface. There's many things that we don't know how to do. And the things which we don't know how to do is basically, of course, how to design machine learning algorithms with few data. This is, I think, will be one of the heart of the problems in the future. Designing also new types of algorithms which can run faster. And the speed of learning is also a big problem for us. And also basically on how you extrapolate learning from one base to another base. And I think people will come up with more and more challenges because also the students will have more and more knowledge based on their background in the universities where we're opening a lot of masters in that. Yeah, I think that's my point of view. However, I mean, we have to say to your public that the future is not only machine learning. We shouldn't put all the people doing just machine learning. You know? Computer science is more open than that. And I think there's a lot other very nice problems to solve in computer science. Yeah.
Okay, that's good to know. We are now at the end of the first hour of the contest, actually 1 hour and 3 minutes just elapsed. There are two clear leaders, University of Warsaw and University of Tokyo, among the contestants. And let's switch to the coaches scoreboard for just a second. Well, the results are not that high at the coach scoreboard, but we definitely see one leader. As far as I know, now we will switch to a short awards ceremony for the first hour. So I'm letting you go. Thank you very much for your visit. And I would be happy to welcome you back during the course of the challenge, if you would like to. Thank you. So in a few minutes, a short award ceremony will take place. We'll try to switch you to that in a moment. Thank you. Short sound check to see if that works.
One,
Can
two,
you hear
one,
me?
two.
Okay,
Yes.
wonderful.
Great.
We can occasionally switch to Russian if you want. Hi, my name is Lydia and I work for ICPC Live, and I do live broadcast of all events. This year we're very happy to welcome ICPC Challenge back as a neural network challenge. Here we have a current scoreboard. It was unfrozen after the award ceremony. Indeed, University of Warsaw women improved their results even more over the few minutes that passed. And we still have a group of leaders. University of Tokyo have been performing great from the very beginning, but we also welcome to the group of 160 and over East China Normal University and University of Illinois at Urbana-Champaign. We'll try to keep an eye on the scoreboard to comment if anything interesting happens. Hi, Michael. Can you tell me what is your role at Huawei?
Yeah, we're developing algorithms that transform raw sensor data into something interesting, something useful. For example, this could be your heart rate, this could be your sleep stage, or this could be a state of some motion object like car. You need to know its position, velocity, orientation, so on. Or it could be a 3D environment reconstruction. So no single sensor can provide you all information. You need to fuse them, mix them, and you need very good skills at mathematical model building, from physical phenomenon to sensor observations, and then you need to solve inverse problem, how to transform these sensor observations into internal state of the object, how to estimate internal state of the object.
So you're a full-time software engineer at Huawei, right?
Yeah, we call ourselves not software engineers but algorithm engineers, because usually we develop algorithm prototype in Python in some high-level language, and actual product coding is usually done at China because it's much more effective.
Oh, wonderful. So you actually program on a little significantly higher level than the one that usually needs to take care of every single, say, bit in the data.
Yeah, because not all algorithms end in pure software. This could be dedicated chip, like we have special accelerated chips for neural nets, for example, like this stuff. That's actually a very practical problem. You need binary neural net, or 4 bits, 8 bits, and it all makes sense when you run it on dedicated special chip.
So well, it's indeed a great idea, because most of the times programmers who indeed participate in the ICPC competitions are very used to the fact that whatever they write, it will be run on basically the same computer they're using
No.
And it kind of significantly moves your understanding on what operations are actually very fast. And you try to optimize that, say, on the compiler level, whereas indeed in Huawei it's very possible to produce dedicated chips. Is it a big practice in the world? Is Huawei basically the main company that can actually do that to make their programs more effective in that way?
Yeah, and in fact at Huawei we have, I can say, full stack from hardware to software. No other company has everything from AI chip, GNSS, CPU, and we have almost full stack, so you are totally free to run your algorithm on heterogeneous hardware or so.
Well, it's a very unique opportunity. Can you tell me a little bit about your background?
Yeah, my background is control theory, so starting from USSR and then to Russia, we have quite a good school at control. So it's also related to navigation, and previously it was navigation for ships, for rockets, so on, so-called inertial navigation, gyroscopes, accelerometers, but now I apply it to consumer devices, and the challenge here is much less accurate than you have hardware at this special navigation application. So you should have very, very efficient algorithms that should work with these small size sensors.
We welcome Moscow Institute of Physics and Technology to the 4th place of the competition. They joined the peloton of leaders at the moment.
Great.
is the low accuracy something that you think in the coming years will be solved by hardware or by software? I mean, I can imagine that it's very expensive to put a very high-end, high-accuracy stuff on, say, every computer in every car in the world. But then, maybe in 10 years?
We don't see any real progress on hardware side for sensors. Sorry, but algorithms, yes. Especially for AI, when you cannot build a model from the first principles from physics, AI helps. If you can collect lots of data, then of course there are traditional areas for AI like computer vision, images,
sure.
Speech, but we are seeing more and more applications of AI for sensor stuff. And one interesting area is health. So being able to understand your wellness status, your emotions. It's very difficult to describe mathematically a human, but you can build an AI model.
I hope. Okay, so that's exactly what you said at the very beginning, that the main focus is on how do you aggregate a huge amount of data that comes from all the different sensors and, I don't know, device information, whether you're active online, checking Facebook 3 times per minute or something, into a more complex term of, say, human perception, their emotional state, in that direction. Do you think that will help us? What global problems will that help us to solve? Well, wellness, obviously.
Yes, wellness, fitness. We don't currently target real medical applications, so that's more about your wellness, fitness, sports related. We try to improve running experience, so make your life easier.
Wow. I'm sure that if it's not an NDA, tell me just in a few words, what would it be a dream to be able to identify in that way? So we definitely can kind of like, cure everything, or make you a better sleeper, make every single time you sleep and nice and healthy, even though it's 4 hours and then the morning before the contest. But what would be ideal to identify, at least to monitor for a person? Or maybe, I don't know, for your house pet?
Well, there is no definition of happiness, but yeah, the final goal is to make you happy.
Wow. Okay, so sounds good
enough.
enough.
We don't know even how to measure happiness, but if we can measure it, then we should improve it.
Yeah, we definitely see the huge improvement and growth in artificial intelligence and specifically machine learning in both the theoretical part, then the practical part, then the application.
Yeah.
And the growth is exponential.
Yeah.
Do you expect this top to that growth in 10 or in 100 years? How many do you think?
100 years, difficult to imagine. I think some next thing will come. Maybe not AI, but yeah, next 10 years is definitely, it will grow exponentially, I think.
Okay. Let's go more on the technical side.
Yeah.
We already discussed that Python is a go-to language for every machine learner and artificial intelligence problem solving. What are the other technical things that, for example, a person whom you want to see in your team should have? Well, algorithms is apparently good. What else?
Yeah, algorithms is must-have. You should have some good math modeling skills. So still for classical navigation problems, students of mechanics are particularly good. So we are looking for talents in mechanics.
Isn't it too real-world-ish? I mean, mathematical mechanics sounds like something that's, like physical modeling. Let's do something. Isn't it like to apply it? I mean, we're all in the clouds now with computers and huge computational resources in our back and everything. Why mathematical modeling? Why physical processes? Aren't we all in a matrix once again?
We are full of real physical objects. So, for example, the next big thing is autonomous cars. So you need to have really good mechanical modeling of how car drives. So you need to have non-holonomic constraints. You need to understand how car can accelerate, and you need very good description of car. Or another is robotics. So robotics is also full of mechanics. So there are some problems that it's difficult to describe by these first principles, but for motion, for navigation, yeah, we still apply it.
I'm sorry for the background noise. Okay, should be fine now. We have a number of contestants are now closing the gap to 160 points on the problem. Do you know the problem?
Yeah, yes.
Do you like it?
Yeah.
Would you solve it? And how many points do you think you can get without any extra effort, say?
I think if I start from the scratch,
yes, please.
Maybe in 10 minutes I would expect something like 20% accuracy for problem B, maybe, I don't know, 10% accuracy for problem A. So I would start from initially some random configuration of weights and do some local search. So yeah, I would accept that kind of numbers. So what I like about this problem is that you can view this as original combinatorial optimization, or you can treat this as you can relax weights from binary to continuous and then add non-linearity after these continuous weights that will convert into binary weights, and then you can do classical backpropagation with continuous weights and move your non-linearity closer and closer to binary weights. But that will require at least 1 hour to set up this solution. But you still can start with some random solution and local search. So that's.
Well, if we are to look at the solution that contestants now submit, what would you look for? What are the best signals that, okay, this is a good solution and there is a room for improvement, and say University of Warsaw can get, I don't know, 10 more points on problem A if they implement this and that? Or what would you look for? I'm sorry for the voice in here. Okay.
Yeah, I'm very interested how they solve this, because just by looking at results, it's difficult to understand how they solve it.
I hope that in a few minutes we'll be able to take a sneak peek at their codes.
Yeah.
Also, we now have almost everyone solves problem in a team of 3. If you are to make it a team of 3, name 2 of your probably colleagues or researchers that you know that are definitely the state-of-the-art researchers in the area whom you would like to solve that problem in a team of 3.
From this university?
No, from whoever in the world.
Oh.
It's very interesting to know indeed who are the best in that area. We definitely know, and everyone will know every top contestant by Thursday, by name and university and picture and everything. So give us a sneak peek on top machine learners in the world.
I would say Konstantin Vorontsov.
Okay.
MIPT is it has a really good school, so you should know, you should derive everything from scratch. Even if you have no access to any materials, so MIPT school teach you how you should derive everything from scratch, and Konstantin Vorontsov is really good at this.
Sounds great. Okay, and you have one more spare place in the team. Whom will it go to? I know it's a difficult question. maybe one of your colleagues.
maybe not so many people know, but I would suggest Dmitry Shmelkin. He's from currently he's with Huawei Research, but many in Moscow mathematical community know about him. So I
Okay,
think
so we'll
he's pretty
definitely
good.
pass on our regards and invite them to the competition next time. I think that they will enjoy that. We know that the question mark in the line 4, if you're wondering what is this, means that the solution is now under evaluation. And as basically every guest of my studio mentions, the very first thing to do would be a random solution. But we only see a really, really low number of submissions that teams do. For example, the University of Warsaw only did 2 submissions on problem A. Like, really small number that doesn't look as a random submission, at least the first one. What is the submission limit on the problems, and what would be your suggestion on how to maybe cut out on totally random solutions? Because as far as I know, everyone sees their, say, final score as soon as they submit a problem, which kind of sings overfitting me. Just send all the solutions and overfit the problem with the test data.
But still, teams can do lots of submissions internally, try on training sets. So I don't think there is really high overfitting. So still they can try many submissions on training set and submit infrequently to validation of test set.
We are now at about the middle of the contest. Once again, typical score would be 150, I think. Let's go a little lower on the scoreboard. But then the second problem looks much more manageable for most of the teams. We can even see a really high score at 93.83 with Fudan University. And I assume that they're kind of hiding the real results without any submissions on problem A so far. What would you do if you have a really good solution on problem B to make it a problem A?
It's strange that they solve problem B but not problem A.
They're trying to hide it. I mean, they're being sneaky. Really, that's the World Finals. Strategic stuff. Oh, wow. I figured I have some extra information from the system. So, indeed, a number of programming languages are available, and here we can see statistics on them. One of the most popular would still be a C++. C++ submissions we'll count for problem B just to make it easier, is 183 submissions in C++, which is fairly typical in the World Finals. We rarely see a submission none in C++. Then the second place would be taken by Python. Python 3 with 119 submissions and 9 submissions on Python 2. Let's let these teams know after the end of the challenge that Python 2 will be deprecated by the end of this year, and we'll celebrate. A number of submissions in PHP. I'm not sure that the data is correct now, but yeah, I think that what system shows me is fairly correct. 3 submissions in Java and even 1 in C#. Even though the most successful submissions are still coming from C++ and Python 3. Is it typical for machine learning? I mean, everyone machine learns in Python, and so we need to adjust the statistic a little bit for the ICPC contestants. But then, really, Python and C++. So if you're just starting
Python, C++.
Programming and you know that machine learning is hyped, you start with Python, right?
And when you get closer to production, of course, C++, yeah.
Okay. What is the division between, for example, your development group between C++ development and Python development? Is it 50-50-ish?
I would say 70% Python and 30% C++. And we have some projects plain C when you have no dynamic memory, when everything is very fixed, especially for embedded devices like this watch. So there are many restrictions, and sometimes there is no even C++ compiler for target platform, so you should use plain C.
Oh, goodness. It sounds like a terrible thing to do. I mean, I know just a few services that still use the plain C in production, but then, indeed, as you said, it's very, very effective in a way. Dum, dum, dum. I hope that, well, the submissions are not looking too exciting. I would be happy to show you one in a second. So, oh no, that won't work. Give me a second. So, well, basically the submission from Warsaw University looks like printf a number of -1s and 1s, which is a-okay. But do you think that actually means that the computation for these values is a more complex program that is written on their computer and can maybe take longer time to compute?
Yeah, it seems their strategy to submit not so frequent, right?
Yes,
And
indeed. They only have
a lot on
a couple
training.
of them. I think 2 submissions on problem A total. Yes, indeed.
And
And the difference with the last submission and the previous one that added, say, 50 points to their code was fairly significant. So huge changes in a line and just a couple of changes in a scoreboard. When do you think we should expect some significant action on that? Do you think that it's possible to implement the full solution within the first hour of the contest and then to be kind of stuck? How did that work?
I would expect something like 2 hours for really something smart.
Okay, so we're closing on that gap.
Yes.
Okay. If you were to give another problem to the contestants, what would you think would it be? I know it's a difficult question. I mean, your colleagues thought about that for half a year or something. Coming up with a problem is always a very difficult part.
Maybe something related to graphs. Graph.
Indeed, there are tons of algorithms using graphs, so that can be, yes, quite an effective thing. Oh, we can definitely see major advancements. So now top, oh my god, 6 teams have 170 and over. Is the difference between the scores in the first group significant in your opinion, or if they just, I don't know, do some random changes, say change a single digit from -1 to 1, it is within a reach from the 6th place to the first one?
Still, I would look not only for score, but also for number of submissions, and Warsaw seems really good with their 2 submissions, so I'm very interested how they do this.
Okay. Well, they already got a prize for the first hour.
Yeah.
So once again, every hour Huawei awards a special prize for the team who's on top. And I assume that the University of Tokyo, who's been the closest second for the whole period of time, would try to do something special at the very end of the second hour. What would you do in that case? Do 100 of submissions, changing a single value of every input from -1 to 1 or vice versa?
Of course, you can try to
Like just a cheat one. I mean,
yes,
just to squeeze through. That's like 1 point, 1.5 points. Solves it all, and it gives you 3 fancy phones. Let's try to, I don't know, spam the system a little bit. Submit 20 solutions at once.
Yeah, you can try to do a local search on score results on test sets. So if number of submissions is not really limited.
I'm not sure. I think the general limit would be something about 100 submissions
100.
per problem. That is usually the reasonable limitation. I'm not familiar with the one set for this particular challenge, though.
So
Or would you leave that for the very end? That's another option.
Yeah.
It's okay, let Warsaw take 6 phones home, but then win at the end.
Yeah, so make few submissions first, and then in the end just do local search to cheat in the end.
Okay, okay, seems good enough for me. Okay, let's take another look at the lower part of the scoreboard. So I've already mentioned Fudan University, who are, in my opinion, hiding the very good solution for the problem. It's very easy to see the submissions that are different in score from the nearbys by their colors. So the greener the solution, the better it is. And we can see a number of very high value solutions down here at around 95 points. And you can see that as soon as these teams submit into problem A, we expect them to, well, not double, but add at least 50% to their existing points. I hope that's exactly what will happen in the coming minutes. And we have other teams, for example, University of Nebraska-Lincoln, who decided to go the other way and to solve a more general problem, and then at the very end to resubmit that. Because will that essentially give you a good result? If you have a nice score, if you identify every single digit, is it just as easy as cut first 30 values and then throw away everything else?
Yes.
Okay, sounds good enough. Okay, so we have 107 teams who did at least one submission. That is fairly good because, once again, I definitely need to mention that most of the contestants are not very familiar with the concept of machine learning, that I definitely did not advance to the World Finals through machine learning competitions. So that can be a very good starting point for most of them. And let's return to the coach scoreboard for a while. We have just a few coaches participating, but I think that's still a great result. And yes, coach scoreboard has a little lower results so far, but once again, Columbia University, Stanford University, and ITMO University are up in the lead and doing good. Most of them, just as their teams, still prefer to start from problem B and then work from the easier problem towards the more difficult one. Well, indeed, it's easier to earn points on problem B right away.
Not much correlation between coach score and team score, right?
I wonder. Yes, indeed. That's very interesting. What resources would you recommend to start machine learning? Well, if you're a world finalist, you're all good. You're getting exposed to the machine learning and neural network challenge during the world finals. But what would you do if you're looking at the stream from home and want to try yourself? Maybe any particular papers to start with or classical publications?
I would start with probability.
Okay.
Probability. So
fundamental
don't just
maths.
Yes, fundamental. Don't treat this as pure optimization problem. You'd better to understand how it relates to probability distributions of what you are trying to model with this neural network.
Okay. Okay, thank you very much for spending your time with me.
Thank you.
If you see anything interesting with the teams, definitely make sure to come over and let me know. We would be happy to incorporate it into the live stream. Nice meeting you.
Nice to meet you.
Have a good
Thank
time.
you.
Whoa. Okay, so just as on the World Finals, we're still looking at the scoreboard. We have partial solutions for problems A and B in here. We assume that 100 points will not be reached by any team within the challenge time. We're now closing to the second award point in just 20 minutes. It is very possible that University of Warsaw will take another set of smartphones from Huawei. But still, I'm sure that University of Tokyo will do their best to overcome them. It's also great to see Moscow Institute of Physics and Technology in the top 3, because we've already heard that one of the top machine learners are working at that university at the moment. And top coach would score among top 20. I hope that I'm calculating that correctly with 166.13 points. Yes, the top coach would place 9th at that moment. We'll be back with the live broadcast.
Clear.
Now you can hear me and each other. I hope well. Is it
Wow.
okay?
Wow.
You can hear me, right?
It's clear now.
Wonderful.
Okay.
And we are back in the broadcast. Hi everyone. I'm back with my colleagues from Huawei who are running that competition right now.
Okay.
We will talk about all the opportunities that Huawei introduces to, first of all, students all over the year. Thank you
Yeah.
very much for that competition. I think everyone is having a lot of fun. We have over 100 teams submitting and
Yeah.
enjoying the problem, which I assume was the purpose. And it's also really good to see coaches finally join their teams on a contest floor. That is something they cannot do for quite some time already. Can you also move a little closer
Yeah,
to me?
no
Would be
problem.
easier.
Okay.
Me too.
Yeah, come on, Sarah.
Yeah,
Here
that
we
would
go.
be better. And it's great to see everyone enjoying the process and doing their best. What are the other cool things that Huawei does for students?
Yes, maybe I go first.
Sure.
Yeah, I really enjoy this moment, you know. Yeah, because in Huawei now we open lots of our research center, and we also meet lots of technology challenge for future. And we are thinking who will have better idea and who will be the future. That's our student. Yeah, they are so smart. That means we needed to support them to give them more programs from industry to help them to identify what's the future program will be. Yeah, according to this procedure, we believe students they can enjoy what the future society technology will be, and also they will have better idea to create for future. That's very important. We in this procedure, we believe we learn each other and we make that better and better for future. Yeah, we both enjoy this procedure.
Wonderful. Yeah, I agree with you. That's a great opportunity.
Yeah.
What is the best way to join you if you're not a world finalist? For example, I hope that we're now followed by a number of people who are in the area of computer science,
Yeah.
but they're not yet world finalists. They're still looking at the possibilities and opportunities. What
Yeah.
would be the first step towards
Okay.
solving your problems?
Yeah, of course, we have also lots of other ways to open to global students who have interest to join something like this. For example, in our different country research center, we open lots of our position and the internship for the student. They could apply to our research center, HRD. We have some website also open all this position and also intern. And also every year in Huawei, in different country, we operate Huawei Technology Challenger in different country. So students, they could also apply to join. For example, in last year, we opened this student challenger in France, in also Poland, in also Italy, lots of country. That's also the topic from industry. Very, very interesting.
Okay. Where is the best and the coolest research center among all the Huawei research centers? Like if I'm the really cool software engineer and I'm looking for not just for an internship opportunity, for the best internship opportunity, what would it be?
Yeah, in fact, according to Huawei's business type, we have lots of product and service and also different research direction. So in Huawei different research center, we also have different direction. That's depend on what's the interest and the future the student will be interested in. For example, in our Paris Research Center and the Moscow Research Center and the St. Petersburg Research Center, these three centers is our algorithm and mathematical research center. Their challenge and the topic much related with this relation, and maybe our ICPC student, they will have more trust in this research center. Yeah.
I see.
Yeah.
You personally connected to one of the research centers. Can you tell me a little bit about your work at Huawei? What do you do and what are your personal interests in that?
Oh, for myself?
Yes.
Okay. Yeah. Now my position is HRD in Euro Research Institute. So you know, in Europe, we also have very widely cooperation with different university and different country. And now my main job is to help different country and different university students to have more chance and opportunity to join into the Huawei industry program. Yeah, to have more opportunity to contact future technology. Yeah, that's also my personal dream. Yeah, I think this is, I found one good platform for me now. Yeah.
Well, sounds like the ICPC is the perfect place for you,
Oh.
because exactly that community is
Exactly.
always connects students with the real industry partners that allows them to figure out the right way and the right direction to go. I have to interrupt you because we have a new leader now, and it is very important as we are closing the end of the second hour.
Wow,
So if
cool.
for 7 minutes nothing changes, this 3/100th of a point will decide the future of the Huawei prizes at the end of the second hour.
Yes.
So now East China Normal University is in the first place with 179.76 points. 3/100th of a point separates first and the second place. It's incredibly small difference.
Yes.
We also can see Princeton University in the top 3.
Yes.
University of Tokyo, even though they have a number of submissions on problem A already, 16, they submitted quite a lot in past time. They are down to the 5th place, but they are still very, very close. So we can see a group of 5 teams being within, say, 2 points reach from each other. That is a very impressive result. You mentioned you have a partnership with different universities.
Yeah.
Can you name a few? We'll try to look up their results, and we'll just discuss their way through ICPC and through Huawei programs.
Yeah, we have a lot of cooperation with different universities. Like in Germany, we have cooperation with TUM. Yeah, and also in France, we have cooperation with the how to spell?
Paritech as
yeah,
well?
yeah.
Paritech, yeah, sure.
Yeah, and also we have cooperation with that's one. Moscow MIPT. Yeah.
Right.
Yeah.
Absolutely.
Yeah. And I think also Belarus State University. Yeah. Yeah, lots of them I noticed. And Moscow State University and also Tokyo University. Yeah.
It is wonderful because you're listing the teams that definitely have been the top competitors in the ICPC for a decade already. And it is a really great result. I hope that you enjoy working with the ICPC alumni.
Amazing, yeah. I really enjoy the time with you together. To be honest, it's my first time to join the ICPC World Final.
Welcome to the World Finals
I feel
then.
very, very exciting, yeah.
I have to warn you though, my first time on the World Finals was in 2012. And I've been working with the World Finals ever since.
Okay.
So be very careful, otherwise you will come to the World Finals every single year for the coming decade, definitely.
I think I have been falling in love. Yeah.
That's exactly the truth.
Okay.
Can you tell me, if I am a high school kid and watching that broadcast from home, it is very easy and clear how to enroll into ICPC competitions.
Yeah.
If you're a high school kid and you're interested in enrolling in an IT university. But what would you suggest for a high schooler, once again, not for a university student, but even earlier, to start working with artificial intelligence and machine learning, maybe to get to Huawei one day?
Of course. Now we are going on to initiate our program. We will aim to more early stage for the student. Yeah, if they have some very high interest in some IT technology or some basic fundamental like mathematical or physical and chemistry, we will give some more, maybe some more opportunity, in this part. Now we are making some program like this. Our idea is a student who has more early think about the future, about technology, we would like to support them. they will be the future, definitely.
That's great. Are you running any other programming competitions that are focused on maybe machine learning and initiatives just to bring machine learning closer to everyone and being that more open?
Yeah. We definitely have some challenger like this. Last year, we operate AI challenger in Sweden, in UK, in France, and Selen could also share these parts. Yeah.
So the challenge in France was, I found it very nice because I wanted to join when I heard of it. So it was actually, the challenge was you get code and you had to say if it was malign code or not. That was actually a machine learning based problem that they have to solve. And the one with the highest precision, they won the challenge, the hackathon. And again, as here, we get great prizes with our challenge that we're organizing today. You could win a prize, but even a cooler prize in my in my eyes was that you had the opportunity to go and visit China. So you saw how Huawei is doing AI and machine learning, what kind of software platforms we have for that. And also, as Sophia was also talking about it, they learn how to build a bridge between the know-how they are taught at universities, or even high school, where you learn, okay, the theory, but then you see it applied, and then that's so much fun, and also real-life problems, because like, for me, that's why I like the hackathon there a lot, was, malign code, using AI to make the next virus wall. It's great to be part of that as well. And then based on that, we were also like, with AI is also a great responsibility about ethics and, how students look at that. Because I think if you look at a lot of policy talks, conferences, there are a lot of professors, which are a bit older, talking about it. But the students who are in our hackathons will be the persons who will be programming in the future. Yeah. So we started asking the participants, what do you think about ethics and explaining machine learning algorithm, how would you do that? And so we said, you know what, we're not going to talk about what students say to us, we'll just join them to the discussion. So we invited them as well to the panel discussions we had at our Brussels hubble, and they talked with policymakers, with the Commission, with the Parliament about AI. And one of the best proposals I heard was using AI to explain AI. I was like, okay, this is so good. But I think that's also very important because it's not only what Huawei can bring to the students, but also what the students can bring to us, because they look at everything with a new perspective, how to attack a problem where we maybe did it differently. They come in real creative ways that we're also happy to learn about. So I think it's a great, I would say, partnership, I would say, that is there, which helps going forward.
Well, that sounds exciting, which marks the end of the 2-hour time. So I think that in a few seconds we'll award contestants from East China Normal University with prizes. I think that you're joining them in a award ceremony.
Definitely, yeah.
Okay. I would be happy then to talk to you later and tell our viewers more about the opportunities at Huawei. Okay. And once again, if you want to tell something or tell everyone what particular website to visit, that would be the right moment to do that.
Yes. One more sentence is now Huawei for Huawei's vision is we would like to connect each family, each organization, each people. That's our vision for future. We meet lots of technology challenges. That means we need to cooperate with the global talent to solve the problem for future. Yeah, let's do it together. Welcome, everyone, and thank you.
That sounds exciting. Thank you very much for being in the live broadcast.
Thank you.
See you.
Okay.